Hello everybody, this is Henri Batouflet, support engineer at IXBlue. Welcome to this session 2 of how to prepare your INS DVL tutorial videos. In this session, I will show two parts, one about configuration of the INS and the DVL, and the second part about quality check all my configuration. So to configure, I'll proceed step by step with a first step that is configuring my INS. For that purpose, I will use this specialist cable that we call the test cable, and I will connect it here. It will allow me to apply power and configure through Ethernet the whole kit. Like in the previous tutorial, I wiggle a little bit this sensor and I can make sure it's properly secure. On this cable, I have a few connectors here, one for Ethernet, two for power here and here, and additional serial connectors that I will not use today, but that you could use for a more in-depth integration. So I'll wire the power of the INS here and the DVL on a separate power supply. It's very important to do so because you maintain a total control of your power configuration. You can recycle power of the INS and the DVL separately. Now that I am plugged, I will go to the second step, which is about preparing my computer. So in my computer, I have a pro tip here for you, is to have a shortcut for your network control panel. I go to the network control panel and I apply power of the INS and DVL, and I'll see my Ethernet network popping up. Once the Ethernet network is popped up, I can configure it. For my Ethernet configuration, I have a strategy to consider, which is for the IP addresses. So IP addresses by default for the INS will be in the 192.168.36.1xx range. The last two digits will be the serial number of the unit, which is here QA-0233. So I will have the 133 IP address for the Rovins Nano, and I choose my computer to be in the 100 value so that I'm sure I can always communicate with it. I click on OK, and now that my Ethernet settings are done, I can configure the INS. So to configure the INS, I have just to launch a new Mozilla Firefox window, type its IP address here, and I will access to the web interface of the Rovins Nano. Something that is very nice is that all the processings and all the MMI settings are done inside that unit. So basically, my computer is just about displaying data and configuring data. To finish to prepare my computer, I also have here a tiny folder with the Nortec DVL configuration file, the INS configuration files, some DVL commands to communicate with the DVL. All that will be fitted inside the box you'll receive the unit with on a tiny USB stick. So now to perform the configuration of my INS, I have to browse to the setting management menu here and click on load settings. So I choose my configuration file for the Rovins Nano. I open it here. I click on load setting. It will take a little while and the unit will restart with its settings applied. So here it's just about the settings of the INS in regards of the DVL, which includes lever arms, protocol parameters, and protocol physical links. For every combination of INS DVL we have for you, there will be a configuration file that will be relevant to your configuration. Now that it is loaded, I can go in the main page and I can see a few things in that page. Here, in the input-output panel, I can see an input C activity. This is right because I connected my DVL on the port C of the unit. I can also see from the DVL tiny light here that it's emitting data as it is blinking blue. Now, the next step of my configuration will be about configuring the DVL. For that purpose, I will go in the input parameters, select the input C, and here I have a small feature which is really nice. It's called Sensor Control Panel, and it allows you to display a tiny hyperterminal window with the data of the sensor flowing in. So here we see unreadable data, because actually we configured the Nortec DVL with the DF21 protocol, which is a binary protocol, so it's not human readable. But still I have full control of my DVL configuration through that tiny portion of the window here. So to communicate with the DVL, I will have first to send a break command. So the break command is this one. I pre-saved it here on a file. I click on enter or return to make sure I send the right command, and also make sure to tick the box for CRLF command. Now I send the request, and the unit will ask me for a confirmation. I type the MC command, return, send the request to the DVL, and here I am. Now I can configure the DVL. So for the DVL configuration, I will take the config file provided also on that tiny USB stick, which is a bunch of commands to configure the right parameters for the DVL that we will expect for it to interface with the unit. I go back here, I paste it here, I make sure I have the return at the end, and I click on send command. Now the unit responds me with OK lines, meaning the configuration went through the unit and OK. The last thing I have to do is to send a start command to make sure the DVL is pinging again, and so that I can receive valid data for my next steps, like the quality check of my integration or the DVL calibration at sea. Now I can go back to my main panel, and I will see that everything is in nominal mode. Now I've finished my full configuration. I will take a few minutes to quality check it and to make sure I'm ready for the DVL calibration at sea. So the first thing I'll do is kind of a reverse order. I will confirm the DVL settings. So to confirm the DVL settings, basically I have input activity here. I could send a bunch of commands to retrieve the DVL configuration. I will show that to you in the extra sessions. And the thing I will very much like to do today is to recycle its power. So it's a basic test, but it will tell me if the DVL starts again normally and boots and sends its data. So for that purpose, I just click here, I power off the DVL, so we can see in the web interface we have no more activity from the DVL. The blinking light is not anymore blinking. I reapply power to the DVL, and it will come back live in my web interface here with the input C status. A small remark here is that I would expect to see some data here, like DVL valid or DVL data received. Because we are in air right now, the DVL is not sending a valid data telegram. So the only method for you to proof check that would be to go at sea and to be in the water to see the data flowing in. The next step would be to fully check my INS configuration, especially if I use a INS that was used before. It might have remains of a previous configuration, so I'll browse all the menus one by one and make sure I have a correct set of settings. I really want to go back to the input, and in the input C, confirm the DVL parameter and set the value for the heading misalignments to -45 degrees here, so that I respect the mechanical misalignments in between the DVL and the INS. It will go faster at sea towards good results for calibration. The last thing I want to do is to interface my extra sensors. Of course, to perform a DVL calibration, I will need a position sensor reference. For that, I have already running a small simulator of sensors that I configured with a GPS at 1 Hz and a sound velocity profiler at 1 Hz on port 8111 and port 8112. So I go to my input parameters. I set the input A to GPS here and receiving over Ethernet the 8111 port, and I will see GPS data is received here through my control panel. And I will do the same also for the SVP. Here, the SVP will send CTD and depth value so that I have a 2-in-1 sensor. I choose to use the SVP70 protocol, Ethernet only, and 8112 protocol. I click on OK to validate the settings, and I click on Sensor Control Panel to see the data flowing in. So going back in the settings, the last thing I want to do is my navigation parameters. Because I will be on a surface vessel, I will configure the altitude mode for GPS altitude, and I click OK to send. The additional settings will be a bunch of features that allow me to optimize a little bit my upcoming DVL calibration. Basically, I really want to check this. In the input window, again through the DVL menu, is the coupled to system. So here I'm on a tight couple configuration. If I were on a AUV or a different vehicle where the DVL and the INS are not physically fit together, I would choose not to couple the system so that the mechanical misalignments for the INS in regard of the vessel are replaced into repropagated into the DVL calibration value. Now I'm very much all set to go at sea for my DVL calibration. To wrap up this tutorial session, what we've seen is that everything was quite easy to configure. Everything was going through the INS. So you saw I just use this test cable, connect over Ethernet, and configure both the INS and DVL through configuration files. Those configuration files, they are provided and tested by IXBlue, which means it's very simple for you to use them and apply them to your units. This is very fast to configure. It took me something like 10 minutes to do the whole setup plus the quality check of it. And of course, we've seen a bunch of small features to make it very simple. In particular, the external sensor panel that allows you to have a direct view of the interface sensors to the INS unit. Thanks for watching this tutorial video, and see you soon for the next video session that will be the calibration at sea.